today in this lecture we are going to talk about arrays. And why do we need arrays? How do we use arrays in Java? So first of all, why do we need arrays? How does arrays help us in optimizing our programming experience? So let's say we have 30 students in our class, and I wanted to store all of these 30 students' grades if I don't use arrays. So if I don't use arrays, I will need to create 30 variables. Each variable will store a value belongs to one student. So this means that I have to manage the 30 variables, and if I wanted to sort those grades, if I wanted to search for a student grade, it will be very difficult because I'm dealing with many variables. So an array is an easier approach to collect data that are related, and they have to have the same data type. So the way that we handle arrays in Java is very similar to the way that we used to handle it in C++. So we handle it such that we have, similar to the idea of a cabinet, we have a first location, a second location, a third location, and etc. etc. So a formal definition of an array is a group of related data items that all have the same name and the same data type. So how do I refer to each item in that array? We have to refer to it using an index. So indices in Java starts with 0 and end with the size -1. So the size of this array is 7. Arrays can be defined using any data type. We can define integer arrays, we can define string arrays, character arrays. It can be in any type of arrays. Arrays are static in that they remain the same size throughout the program execution. If I define my array to be the size of 5, throughout the program execution, the size will not change. So every item in an array has a specific position. That position in Java, we call it an index or a superscript. The first index, we also call a base index, is always 0. So if I have an integer array, so let's say this array is an integer array, then that means how much space do we have to store for this integer array in our memory? Since it's an integer array, then every item should have 4 bytes, and because we have 10 items or 10 values, then we have 4 times 10, and that gives us 40 bytes for the entire array. So how do we create an array? First, we need to declare the array before we can use it. To declare an array, we can write it in this format. We start with the type, whether it's integer, string, character, float, whatever type that I choose, and then the square brackets, and then we give it the name, and finally we end it with a semicolon. So here we have an example. We can write it this way, and we can also write it this way. The first way is preferable, but the second way is also compiled and doesn't give you any errors. So you can write it either this way or that way. So by the end of this step, we declared a array. We didn't give it a size yet. It doesn't store any values in memory for array values. We just declared a array variable. So after declaring an array variable, we need to allocate memory for the storage of the array items. How do we do that? We need to define that array. We define an array by using the new operator. So here we have the array name is equal to new, and then we have to say the type, what is the type of this array, and then we will include the size within this array. So here we have a is equal to new int 5, which means that the array the array A has a size of 5, which is what we can see here. So can we declare and define using the same statement? Yes. So here we declared and defined the array. We have an integer array, and we use the square brackets to notify the compiler that this is an array, not a single variable. And then we gave it a name, is equal to new int, and then we gave it a size of 5. And here we also have another example. So the way that we define an array is we must use the new operator, as we've seen before. Here we have an example of writing it in 2 statements, and we can also write it in a single statement. So here we wrote it int, and then in this step we declared the array, and then we defined the array values, and we also included the size. We can also use it or write it in a single statement, such as this statement here. So how do I find the length of an array? Let's say we passed an array to a method, and within that method I want to know what is the length of that array. Then I will have to write the name of that array and then dot length. And I highlighted this in blue because in your slides there's a space. It's a typo. This is the name of this array. So now that I have the length here, I want to store it in a variable, and in this case we called this variable array length, and the type of that array is an integer. So what is the default initialization of values in an array? If the array was defined in a numeric primitive data type, such as double, float, integer, then the default value will be 0. If it was a character, then the default value will be this value right here, which is the Unicode equivalent of null. And in Boolean, it will be false. The default value will be false. So here in this example, as we've seen, we declared and defined an array. We called it int array, and it has a size of 4,000. We can also initialize the array elements by specifying it in this way. So here we defined an array, which we called int array, and we also initialized this array. So the size of this array will be the number of elements that we have. So here, for example, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 9 elements of this array. I think I miscalculated. 3, 4, 5, 6, 10. 10. Yes. So this array has 10. And the way that we fill them is each one of them will have its own location, and the indices starts from 0 until 9. But we have to be careful. We can't write it this way by writing double and then square brackets my list and then initializing it this way. The initialization part must be at the beginning. Okay, now moving on to accessing array elements. Now that we know how to declare and define and initialize an array, now let's see how we can access array elements after we've already initialized them, or if we want to assign a new value to an array element. So for example, here we have an integer int temp variable is equal to int array at index 3. So what we do here is we get the content of the fourth element in the int array. So we'll have to see what is in int array at index 3. Let's assume that this is what has been filled before. So what will be stored in the temp variable will be 10. If the int array was empty ahead of this statement, then what we'll find in array at index 3 will be 0. And then here we have int array at index 7 is equal to 66. What we did here is we assigned or inserted 66 in the int array at index 7. So at index 7 we assigned the value 66. And then the third statement, we created a variable called k and we gave it a value of 3, and then we moved to int array at index 3 is equal to 10. So we had this to equal to 10. So the statement here compared to the statement here is that in the first statement we added the value inside the array to the temp variable, and here we assigned the variable we assigned the array with the value of 10. So here it was an assignment, and here we the value inside the int array at index 3 will be stored in the temp variable. So what happens if we try to access an index that is less than 0 or greater than the highest index in the array or equal to the size? We will get an array index out of bounds runtime error. So we shouldn't try to access the index -1 or equal to or greater than the size. So pause the video to try to find the output of this activity by yourself, and then rewind and then continue with the video to check the answer of the activity. And just a reminder that here you have to have a semicolon. It's a typo. It is part of the code. And record your answer. So the answer here, it should be that an integer array called array1, it has a new int with a size of 5. And we also have another array called array2, and this array we initialized it with these values. So array1, the initialization of the integers will be the default value, which is 0. So we have 5 integers of zeros. And in the second array, because we initialized in the same statement, that means we have 4. The size of this array is 4, and these are the values in those 4 elements. Now moving on to system.out.println, array1 at index 4, the first array at index 4, and then we have the output here. And this will give us array4 is equal to 0, because we have default values in array1. And then array2 at index 3, index 3 is 0, 1, 2, 3, which is -2. And then finally array2 at index 4, array2 at index 4, this is index 0, 1, 2, 3. We don't have index 4, so as I told you before in the last slide, we will get a runtime error, which is array index out of bounds. So if you get this error in your Java program, it is easy for you to know what is the cause of this error, because now we know that array index out of bounds exception means that we try to access a memory location that is not part of the array. So this helps you know or troubleshoot your program. Okay, so in the next activity, I would also suggest that you pause the video and then resume when you finish the activity. So we start the execution as always, starting with the main method, and then here we created similar to the previous activity, we created two arrays. The first array has 5 elements initialized with 0. The second array has 4 elements, and we gave it initialization. So what would be the output if we printed array 1 at index 1 plus array 2 at index 2? So it will print this statement as it is, and then here's the tricky part. Array 1 at index 1 should be 0 because we didn't initialize here, so we will have the default value. This is 0. And then plus array 1 at index 2, array 1, this is array 1 at index 2 is also 0. So the tricky part is that here, because we have a string at the beginning plus a numeric value, it will concatenate these two values. It will not do addition first, it will do concatenation. So the answer here will be array 1 at index 1 plus array 2 at index 2, and then space 0 0. The next statement will be array 2 at index 1 and array 2 at index 3, and it will print 6 minus 2. Again, for the same reason, because it's concatenating strings, because the first statement was a string and the plus sign with strings is used for concatenation. So the output will be, as I said, 0 0 for the first for this first print statement, and 6 minus 2 for the second print statement. So now what if I want to access all of the elements? Let's say I wanted to print all of the elements in the array, or assign all of the elements in the array by the user. In this case, we need to use a loop. We have two options for using loops. The first option, which is the most popular option, is to use it in the normal way that we are very comfortable with. We write for int I is equal to 0. We start with the first index. I is less than the array.length, and then I plus plus. Within that for loop, then we can do whatever statements that we want. If we will print, we will say system.out.print, and then between parentheses we'll say, for example, array at index I to print that statement. Another method is an enhanced for loop, or also we call it a for each loop. The syntax for a for each loop is that we will write for, and then we will write the type of this array. If it's an int, we'll write int. If it's an integer, we'll write int. If it's a double, we'll write double. Float, string, char, we will write the data type here, and then here we'll define a variable, any variable name, and then here after the colon we will define, or we will type the name of the array. And then within the statements, the body of the for loop, we will manipulate the elements in the array using the var variable. So the var here is the value in the array, it's not the index. Here we are in our for loop, we defined I, and we manipulated the array using the index I. But in an enhanced for loop, we are manipulating directly with the value, not the index. So we cannot say array at index var, for example. This will give you a logic error, or it could give you a runtime error depending on what we get in var. But it will not give you the value in the array if we write it this way. Okay? So just to make it clearer, here we created an array and it has 5 elements, 10, 20, 30, 40, and 50, and we used an enhanced loop and a normal for loop. It will give us the exact same result. Okay, so this is just a note to be careful with when we're dealing with a enhanced for loop. Then the value that we have here is the value in the array. It is not the index. When we're using a normal for loop, the value that we have here, or the value that we declare and initialize, is our index to our loop. Okay, so again, pause the video, try to finish this activity, and then resume the video. So here we have, in this code segment, we have two methods. We always start execution with the main method, and in the main method we have a marks array. In the marks array, we have these marks for some students, and after that, after defining this marks array, we have a max marks integer, and we get the value of this max marks from a method called maximum, and we pass the marks to this maximum method. And it's important to note that in arrays we pass arrays by reference, while any other primitive type we pass them by value. So what do we mean by passing by reference, passing by value? What that means is when we send an array to a method, the values in the array, if they were changed in the method, it will be reflected back to its calling function or calling method. So if I change 125 in this calling method, that is maximum, and then we continue to try to access this first element, it will be changed, reflecting the change that happened here in the maximum method. But if it was a primitive data type, such as a double, an integer, a character, then it will send a copy to this method, and then this method will be handling this copy. And when we return to the main method, or the return to the calling function, then the value there will not be changed, reflecting to the maximum method, unless we assign it to it. Unless we assign the new value that we got here using the return into this variable. Otherwise, the value will not be changed. So in the next example, we will see this in a more clearer form. So here we pass the marks to the maximum method, and in the maximum method we have a max variable. We start with the base index at 0, numbers at 0, and then we have a for loop, which is an enhanced loop. It has an integer. We are going through integers with a variable called num, and we will pass this num variable throughout all of the elements in the numbers array. So in every element, or in every iteration of the for loop, we are comparing if this num that we are passing through right now is greater than the max. If it was, then the maximum value will be equal to this num value. And then by the end of this for loop, we will get the maximum value, and then the last statement, we will return this maximum value, and it will be stored in max marks. Finally, we'll print system.out.println, the highest score is max marks, and the maximum mark will be 132. So the output should be the highest score is 132. Okay, so we also have a activity 8, but we will discuss it in the next lecture, because activity 8 deals with objects and classes, and we still didn't cover that until now. So as I said at the beginning of the lecture, we use arrays for many different reasons. The first reason is to combine a lot of related information together, and we can also easily manipulate that information. We can copy arrays, we can manipulate arrays, we can search through arrays, we can sort arrays. So copying an array, how do we copy an array? Can we copy it this way? No, this will not work. What we can do is we have two options. The first option is we can create a for loop, and we copy elements from the first array to the next array by going through element by element in those arrays. So for example, here we have an integer array called array1, and it has 5 values, and I want to create a copy of that array and call it array2 is equal to new int, and then I will give it a size equal to the size of the first array. So array1.length, this will give you a result of 5. And then element by element, starting with the base index at 0 less than the array length, and I will copy every element in that array. So array2 at index I will be equal to array1 at index I, and this will give me a copy of array1 in array2. Another option is that in Java we can use an array copy utility, which is a method that we can use. It is in the system class. So whenever we need to write it, we'll write system.arrayCopy, and then the first argument will be the first array, the second argument is the source position, and then the second array, the destination or the target position, and then we define the length. How many elements of the original array do we want to copy? Do we want to copy the whole array? In that case, we will write array.length. If we want to copy 2 elements, 3 elements, 5 elements, then we will write that in array at the last argument. So an example of using this method, let's say we have here the array, and we have, let's say I have another array that I want to copy the values to. Let's call it array2, and this array is new int, and its size is the same size of the original array. Now we will use the method array copy, and we will write, as I said, the source array, and then the source position, the second array, and the second position, and then here how many elements that we want to copy. If I want to copy all of the elements, I will write array.length. So just to see the results here, so it gave me a copy of the original array. So what about these arguments? What do they mean? Let's say I change this from the 0 index to the 1 index. That means that I will start copying from here instead of start copying from the first index. And then let's say I want to copy only 2 elements. So what that means is I will copy starting from index 1, I will copy 2 elements. So I will copy these 2 elements. Where do I store them in the new array? Or where do I store them in array 2? Depending on what position I start with here. So if I start with position 0, that means the first element and the second element will be 20 and 30, and then the rest of the elements will be zeros, because that's the default value. So let's see this in action. We will see here 20, 30, and then the rest is 0. Of course, I can change that. I can allow it to start at index 2, for example. So it will be 0, 0, and then 20, 30, and then another 0, as we can see here. So it depends on what we want our array to copy. Do we want to copy the full array, a part of the array, and in what positions do we want it to be copied? We can also use an anonymous array. What is an anonymous array? An anonymous array is when we need to use an array only once and not refer to it again. In this case, we can use an anonymous array. So the way that we define an anonymous array is that we will not need to give it a name. So for example, here we have here we can see the differences between creating a array that has a name, a normal array, and creating an anonymous array. So when we create a normal array and pass it to a method, what we usually do is first we give it a data type, square brackets, a name, and then equals to, and then define or initialize it with some values. And then we will send this list within the print method. And then the print method, whatever it's going on inside here in this print method, it will print all of the values. It will execute that and then return to its calling function or its calling method. If we use an anonymous array, then we will not, instead of sending a named array, we will send an array that doesn't have a name. So we will send new int and then the square brackets to say that it's an array, and then the values within that array. So this is an example of an anonymous array. And the way that it's handled in Java, it is the same exact way as if it had a name. It will be sent to this method. This method will receive an array. It will give it a name in the method, which is called array. It will handle it, leave the method, and then when we return to the calling function, it does not have a name, and therefore we cannot use it again. So again, pause the video and try to find the output by yourself. Then resume the video, and we all know that we always start with the main method, and then in the main method we have an integer called x with a value of 1, and we also defined an array that we called y with 10 integers. Then we sent to a method called test x and y, and then we will move to to the test method with the variables x and y, and we know that x has been passed by value while y was passed by reference, because x is a primitive type, it's an integer, while y is a reference type. So here in the method test, we changed the number to 1001, while the array at index 0, array numbers at index 0 is equal to 5555. So now that we ended the test method, we'll return back to the next statement following the call of the test method. So returning here, we have a print statement. So we print x, and as we said, because we just sent a copy of x, we didn't send the memory location of x. X will be printed as it is, so it will say x is, instead of the equals, 1. And the next statement is also a print statement. It will print y at index 0 is, fixed it this time, and y at index 0, because it was passed by reference, then the value will be 5555. So this will be the output. So when we have an array and we send an array to a method, can we return an array? Yes, we can. So we can have the return type of a method be an array, such as we can see here in this example. So in this example, we created this class, and what we want to do in this program is we have an array. This array is called list, and it has the numbers from 1 to 6. What we want to do is, using this method, the reverse method, we want to reverse the elements of list 1 in a new list called list 2. So we start execution from the main method, and then here we created an array. This array has list 1. So here we have list 1, which has 6 elements, 1 up to 6, 1, 2, 3, 4, 5, and 6. And we know the indices is 0, 1, 2, 3, 4, 5. The next statement, we created an array, which is list 2, and the content of list 2 comes from the reverse method, which has list 1 as its argument. So we go to the reverse method, which accepts a array as an argument, and here we created a result array which has a length exactly the same as the length of the list 1. So here we have a new array called result, and in this array it has the same size as list. So it also has 6 elements. By default, since we didn't assign it to any elements, by default the elements inside the result array at the beginning is 0. So here we have 6 zeros at the statement. Then, as we said, since this method is to reverse the elements, we want the result to be from 6 to 1. How will it do that? By using this for loop statement. So in this for loop statement, we have two variables. We have I is equal to 0 and j is equal to result dot length minus 1. So I is equal to 0, and this is I, and then j is equal to result dot length, which is 6, because we have 6 elements, minus 1 is 5. And then before entering the body of the loop, we have to check that the condition is true. So I is less than the length, yes it is. I is 0, so it is less than the length. So now we can enter the body of the loop. So in the body it says that the result at index j, where is index j? It is at j is equal to 5. So this is index j. This is the array result. This is index j. And what will we enter here at index j? It is equal to array at index 1. Sorry, at index I. So this is index I at the beginning because it's at index 0. So the content is 1. So we'll replace the 0 here. It will become 1. Now that we ended the statements of the body, we will go to the update. We will update I. It will become 1. J, because it's a decrement, it will become 4. So to visualize it, I will become at the second index, and j will become the second index from the end. So here we will have our j. So now that we have completed the update, we again check the condition. Is the new I still less than the length? Yes, it is. So the result at index j will become the value at array at index I, which is 1 right now. So array at index j will be equal to list at index I. So it will become 2. And then we update. So I will be 2 and j will be 3. We check the condition. The condition is still true. So we will execute the statement in the body. So to visualize it, now I is here and j is here. So we will, as we usually do, result at index j will be equal to the array at index I. So here we'll have 3. And we see that it is correctly reversing, and if we continue execution, we will have 4 here, 5 here, and then the last statement we'll have 6 here. So we will have this array reversed. And at the end, after we completed the reversing, we will send this new array that has the elements 6, 5, 3, 2, 1, back to the main method, and we will store this array in a list called in an array called list2. So we will store this result in an array that we call list2. And we also have other operations that we can do with arrays. Here we reversed, and before that we used copying of arrays. So we have multiple ways to manipulate an array. Now we'll look at how we can search through an array. So searching through an array is very simple. If we have, for example, a key that we want to look for in the array, we will have to specify what is that key, and then one by one we will go through all the elements of the array to check if that key is found or not. So let's say that we have a main method. We're not going to need this in this example. So we have a method that is called search, and within this method we have a for loop, and we will go through all of the elements in the list array to check for a certain key. So we will start our for loop from the first index. We will check that I is less than the length, and we keep incrementing I. And then our condition will be if the key is equals to the list element that we're at right now at index I, then I want you to print that the key exists at this index. So in this visual example, at the first index it does not exist. We will move on to the next index. It does not exist. The third index, it does not exist. The fourth index, it does not exist. The fifth does not exist. And we finally found it at the sixth element. And it will print key exists, the key, which is 3, exists at, and then the index. What about sorting? We can also sort arrays. So we have two ways of sorting an array. We can sort an array ascendingly or descendingly. So there are many methods that we can use for sorting in the Java util arrays class, and we will use the Java util arrays sort method. So if we want to sort elements from the smallest to the largest ascendingly, we will use this method. So here we have an example. We have a double array that is called numbers, and we have a collection of numbers. So to sort them is very simple. We will just use java.util.arrays.sort, and then we enter the name of the array, and it will sort it ascendingly. The same goes for character arrays. We can use the java.util.arrays.sort and enter the character arrays, and it will sort them using the ASCII codes. So if you guys remember, the capital A in ASCII is 65 and the small letter A is 97. So it will start from the capital letters to the small letters. And if we also have numbers which can be represented in characters, they are in the beginning of the ASCII table. So if we print the chars array after sorting, this will be our result. And then in Java 8, it provides a method that is called arrays.parallel_sort, and this method allows us to make use of the multi-core in our systems for faster sorting, because we know that sorting is an expensive method. The larger the array is, the harder it is to sort, the more expensive it is. So therefore, we need ways to make it more efficient. So one of those ways is to make use of the multi-core in our system and use each of those cores to parallel sort the array. So this method is just for speed. It will not give us a different result. It will just speed up the execution of the sorting. And it's provided in Java 8, not earlier than that. So now we've covered single dimensional array. What we covered in single dimensional array, we can also extend that idea to multi-dimensional arrays. Dimensional array, we use linear collection of elements. When our data is linear, we use a one-dimensional array, but in some cases, our data, we need to represent it as a table or a matrix. So in that case, we need a two-dimensional array. So for example, here we have information about the distance between two cities in the United States. For example, here we have the distance between Chicago and Chicago is 0, but from Chicago and Boston it is 983. And we also have other examples, such as, for example, we have if we're representing information about students in a single classroom, then we can use a single dimensional array. But if it's, for example, I wanted to see the results of a quiz of a single classroom, I can use a single dimensional array. But what if I wanted to know what is the grades of 4 groups? Then in that case, every row should represent one of those sections. Another example is if I'm not only looking into one exam, but all of the classwork, for example, your quiz, your midterm, your final exam, and your other quiz, your project, then I need a two-dimensional array or a table to represent every student's grades in a batch. So these are all examples of when we need to use two-dimensional arrays. So the way that we write them in Java is very similar to the way that we used to write them in C++. We will write the data type. For example, it could be double, char, string, whatever data type that you choose. And then you will add two square brackets because we're looking into two-dimensional arrays. And then we write the name of this array. And then we open a curly braces and end the array with a curly braces, and we don't forget the semicolon. Then every row inside this matrix, we started with a curly braces and end it with a curly braces, and within that we write all of the elements. And then to show that we are going into a new row, we add a comma and then again start a curly braces and end the row with a curly braces. And this goes on for all of the rows. So here we have 1, 2, 3, 4, 5, 6, and 7. We have 7 rows, and we have 1, 2, 3, 4, 5, 6, 7 columns. So this matrix is 7 by 7, and that is because we have 7 rows and 7 columns. So declaring the rows and the arrangement of rows and columns, we know that the rows represents this side and the columns are from the top. And the way that we write them is the first index is the index of the row, the second index is the index of the column. So this is row 1, column 0, and this is row 0 and column 1. So creating a 2D array, as I said, we'll write the type, two square brackets, and then the name of the variable, and we can write it this way or that way. It is both equivalent. And then when we declare a two-dimensional array, we can write it this way by writing int and then 2 square brackets, the name of the matrix, and then end a statement, and in another statement we say that the matrix is equal to new int, and then we declare the size of this two-dimensional array. Or we can write them all in one statement. We can write it as int, the 2 square brackets, the name of the matrix is equal to new int 10 by 10, or we can write the square brackets after the name of the matrix. All of these three are equivalent. We can write it in 2 statements, we can write it in a single statement, and we can either precede it with the square brackets, or we can start with the name of the matrix. So in a single dimensional array, we only need one for loop to iterate through all of the elements in the array, but that is not the case when we have two for loops. When we have 2 dimensions. When we have 2 dimensions and we want to iterate through all of the elements, we need 2 for loops. So the first for loop, or the outer loop, we start with an index. It could be called I, for example, and that is equal to 0, and then index I is less than the matrix dot length, which means we are looking at the rows in this case, and I is updated by 1, and in the inner loop we add another for loop where j is equal to 0, j is less than index I dot length, and then j plus plus, which means here we're looking into the columns, and then the matrix at index I and index j is equal to int math.random times 1000. And what this means is we want to assign random integers in this array. So we know how to use the math.random from the first lecture, and then we casted this value into an integer. So we can use a initializer. We can initialize the values. We have 2 ways to initialize the values. Either we write it this way, we type int and then the square brackets for the 2 dimensions, the name of the array is equal to, and we open a curly braces and we enter all of the elements that we want to initialize, or we can write them statement by statement, index by index, the values of these elements. Both of them are equivalent. Usually we like to see this one because it's very simple, it's easy on the eye, it's very easy to for readability, but this one is also correct. Now we're looking into a new concept. This new concept is a ragged array. What does that mean? It means that sometimes we don't need the array to be full in its length. So for example, what we usually see as a 2-dimensional array is a rectangular array. So we have the same number of rows, the same number of columns. But sometimes it's inefficient to have the same number of columns. Because what if, for example, in my first row, I only need 3 elements. I know for a fact that I won't need the fourth and fifth element. But in the second row, I need 5 elements. And in the third row, I only need 2 elements. So if I use a 2-dimensional array in a rectangular form, then I'm wasting a lot of space that I know for a fact I won't need. So the way to try to have more efficient memory allocation is to use a ragged array. And what that means is that in a ragged array, each row can have different length. So the way that we express this in Java is we can write it this way. So for example, here we have an integer array, and we specify that we have 2 square brackets as in 2 dimensions, and then we write the name of the array is equal to, and then we open the curly braces as we usually do and end it with the curly braces. But here's the catch. When we enter the elements within each row, this can be of different sizes. So now, if we enter matrix.length, which we know it will tell us how many rows that we have in this matrix, it will tell us that we have 5 rows. And this is correct because here, this is the first row, second, third, fourth, and fifth. We have 5 rows. But matrix at index 0, so this is index 1, this is this is index 0, this is row 0, this is row 1, row 2, row 3, and row 4. So matrix at index 0, at row 0, the length is 5 because we have 5 elements. And then matrix at index 1, which is row 1, we have 4 elements. So the length here is 4. And similarly, matrix at index 2, we have 3 elements. Matrix at index 3, we have 2 elements. And then matrix at index 4, we have 1 element. So here is another example. If we wanted to write it in the equivalent method, so as we said, we can write our array in this form or in this form. Now I'm going to show you in this form how it would look like. So similarly, we have another way of defining a ragged array, and I will show it to you now. So we can write it also as int, which is the data type, and then 2 square brackets defining that we have a 2-dimensional array, and then the name of that array is equal to new int, which is a data type, and then here we have to specify how many rows. The reason that we have to specify the number of rows is because it tells me how many memory locations do I need. I don't need to specify how many columns because I might have different lengths. So that is why when we write the syntax of a new integer array, which is of 2 dimensions, we at least have to write the number of rows, but we don't need to write the number of columns. Because if we have to write the number of columns, let's say 4, just as an example, this will mean that we have 5 rows and exactly 4 columns for each. And in that case, we can't write a ragged array. So for that reason, we must specify the rows, but we do not need to specify the columns. But if we write it this way, this will be wrong, where we don't specify neither the rows or the columns, because this way we don't tell the compiler anything or any information about this array. So going back here, what the compiler now knows is that I will store 5 memory locations. And then what it actually does is that triangle array at index 0, which is this array, it will reference, now we're looking more into detail about how the memory looks into 2-dimensional arrays. The way that the memory sees it, or the way that Java translates this to the RAM, is that at index 0 of a 2-dimensional array, we will reference it. So the triangle array at index 0, it will hold a reference to a new array that has a size of 5. And then the triangle array at index 1, it will hold a reference to a singular array or a 1-dimensional array that has a size of 4. And then the triangle array at index 2, it will reference a single-dimensional array of size 3. And then at index 3, the same, it will hold a reference of a single-dimensional array of size 2. And finally, at index 4, it will hold an array of size 1. So this is looking into details of how Java really stores 2-dimensional arrays. And here it further shows you how they are handled. So if we have a 2-dimensional array that is full rectangular, let's say for example it has a size of 3 by 4. So the way that it's handled is that we have an array that is called A. This array is a single-dimensional array that has 3 elements, which represent the rows. And then in the first row, at index 0, what it does is that it holds a single dimensional array representing the first row. And at index 1, which is this index, it references a one-dimensional array that holds 4 elements, which is row 1. And then at index 2, it references a single dimensional array of size 4 that holds these elements. So what I'm trying to say here is that using a two-dimensional array in the memory is expensive if we want it to be exactly this way, because that means I have to have 12 consecutive elements in the memory, which might not be available. So a more efficient way to store this information is to have a one-dimensional array that references other one-dimensional array. So that way I just need 4 consecutive data to be together instead of needing 12 in this case. And the same idea can be extended to multidimensional arrays, not only 2 dimensions. So moving back here, so again, as we usually do, pause the video, try to find the output, and then resume, and we will start execution as always, starting from the main method. So in the main method, we have a matrix, a 2-dimensional matrix that is called mat, and we send that matrix to a method called print array. We are going to the method print array, and then we used an enhanced loop, and we can see here that in the enhanced loop we have an int array that references a row, and at the other end of the colon we have the matrix, and then within it we have another for loop, an inner for loop with an integer of a variable x, and then at the other end of the colon we have the row, and then we print the x value. The reason that we write it in this form is because we know that we need 2 for loops. Each of them will be for the rows and the columns, and the first for loop we write it this way is because, as we said, a matrix includes multiple rows, and each row is in itself a one-dimensional array. So we have to write it this way. And then in the inner loop, because each row is an array, we represent it at the right-hand side of the colon, and then every value of the columns is a variable, and then we can print that value. So the answer here will be the every value in the matrix, and separating them we have a space. Activity 20 tells you that what will be the output of the following code segment. Can we define a 3-dimensional array? Yes, of course we can. We just need to add a third square brackets, and then in the definition we also add a third square bracket. We don't need them to be all the same, not because it's a 3-dimensional array means that they have to be 3 by 3 by 3. It can be any number. It can be 2 by 5 by 7. It can be any number. And what if we want it to be a 4-dimensional array? Then we just need to add a 4th square brackets, and then in the definition we also have to add a 4th dimension. So how would we create a 7-dimensional array? Very similar. We will have 7 square brackets at the beginning, and then 7 brackets at the definition. So now we will move on to enumerated types. So an enumeration or an enum type It is a special data type that creates a set of predefined constants. So sometimes we have predefined constants. We have constants that we need the user or our fellow developers to use. We don't want them to mistake them for any other variable. We don't want them to mistake them for any other string. So we can create our own data type, and which is called an enum type. So, for example, one of the most common examples is that we know the months of a year. We know that the months of the year will not change. They start from January, end with December, and we want the user to enter those frequently in our code, let's say. So in that case, we can create a data type instead of using a string that is called month. What do we benefit from creating this data type is that we make sure that the user, or in this case a fellow developer, does not mistakenly write January in an incorrect spelling and causing our program to give us a logic error because of this misspelling. So in that case, if we used an enum instead of a string and the user misspelled, in that case we will get a compilation error. It will tell the programmer that no, this is not one of the types that we are defining in our enum. This is not one of the predefined constants. You must be mistaken. So it is less error prone. So to teach you that with an example, the way that we write an enum data type, we will start with static. We will then explain what static means, and then we will type enum and then the name of the enumeration. So here we chose day because in this program we're dealing with days a lot, so we will call it day and then we enter all the days of the week. We start with a curly braces and then enter the name of the days one by one. We call them constants because these values are not changing, and we follow the same convention as constants. We use capital letters for all of the letters in the words, and we do not, and make sure not to mistake that we do not use the double quotation marks between those between the words. And then we end it with a curly braces with a semicolon. So now, if we want in our main method to declare a new day, which is a data type, we use it in a similar way that we use integers, characters, and other primitive data types. We will write the data type first, the name of the variable, and then we assign it to a value. So here the data type is day, and the name of the variable is day 1, and then we will assign it to a value. That value is day.Friday. Another example, we can define another day, and here in this example we used the data type day. Day 2 is equal to day Thursday. So before I move into the rest of the code, I just want to tell you two methods that we use with enumerated objects. The first method is the name method. The name method returns a string. This string is the name of the value of the object. And the second method is ordinal. Ordinal returns an integer, and this integer tells me what is the order of the value of the enumerated object that we have. So to make this more clear, at statement 9 or at line 9, we have day 1's name is day1.name, and then this will give us in a string format the name of that day. So in this example, day 1 is Friday, so here it should replace this with Friday. So as we can see here, day 1's name is Friday. Day 2's name is Thursday, that should be the output, and then day 1's ordinal is day1.ordinal, Ordinal tells me the order of that day. So the order starts with index 0. So Sunday is 0, Monday is 1, Tuesday is 2, Wednesday is 3, Thursday is 4, Friday is 5, and Saturday is 6. So day 1, which is Friday, should be 5, and that was our result. Day 2, ordinal, it should give us 4, and that was our result. And then here, if we want to compare 2 days, day 1 dot equals day 2, are they equal or not? This is what the equals means if we refresh back to the first lecture. And obviously they're not equal, so the result is false. And then day 1 dot toString will turn this day to a string, and it will print the name of that day, which is Friday. And then finally, if we want to compare 2 days, it will either return 1, 0, or -1 if we get if day 1 is greater than day 2, it should give us 1. If they are equal, it should give us 0. If it's less, it should give us less than or -1. So here in this example, day 1, which is Friday, and Friday is at index 5, and day 2 is Thursday, which is at index 4, so 5 is greater than 4. The result is 1. So here we have an example. We have 2 activities, and I changed it a bit just to remove the parts of the object and classes that we haven't discussed up until now. So I modified the activity just to reflect the things that you already know without overcomplicating it. So again, pause the video, try to find the solution by yourself, the output, and then resume to see the correct result. So as we always do, we start with the main method. We declared a day and we give it a value of Friday, and then we called a method called ifEnum, and we sent the day to that method. Then we go to that method and then check these statements. Since it is not a Sunday or a Monday or a Tuesday, we will go to the else statement and it will print it is Saturday. Activity 2, again we start with the main method. Day is equal to Friday. We go to the method called switchEnum, and we sent the day to that method. And then here we have in the switch statement, we have Friday as one of those cases, so it will print Fridays are the best. Then because we have a following break, we will get out of the switch statement and the method ended. So we go back to the main, and the main method also ended, so that is our output. So thank you all for listening. This is the end of lecture 3.